Okay. All right. It should be recorded. All right, everyone, I'm going to just go over Unit 7 on proteins, some basic things on protein, and I'll be letting you know um, what I'll be looking for on the exam. So if you pay attention, watch the videos, you should do well. All right. I'm going to just say, not part of the chapter, but I'm a little concerned about the lack of effort, most people in discussion. So I did offer you guys the second discussion on the microbiome. I think last time I checked, there was 4 or possibly 5 people in it. So I don't know if you guys read the rubric or the syllabus, or I mean, I know some of us are a little unmotivated due to the circumstances, and now the weather's getting nicer, but please realize the course is ending soon in May due to the circumstances. There's no breaks. So I'm hoping that you guys knew that. All right, so please get into your thought mode for your midterm reflections. All right, they're not worth a whole lot of points, but some of you are going to need some points. I've already discussed my concerns with the appropriate people as far as the course. So I've given everyone an opportunity to do the discussions. I dropped your lowest test grade. I've given you guys the extra discussion. Listen, if you're not in discussion, you can't incorporate that component into your midterm reflection, but that's your choice. All right. So the discussions are there. They should be an easy 100%. You can do them anytime you want. Just jumping in and posting a paragraph on something you read or something that's already in the book or something that's already been discussed is just not acceptable as per the rubric. So there, I've gotten that not really off my chest, but uh, I've explained it, so it's not like you haven't been told or it hasn't been expressed. All right. So I'm going to choose my mouse. I have my new XP drawing pen that does not seem to be working. It's supposed to be some kind of a stylus with a pad so I can annotate PowerPoint, but it just does not seem to be working on the MacBook. It doesn't work much better on the ThinkPad. So not sure, but I will get through it. And I just read the book. It took me literally about maybe a little over an hour, and I highlighted some test questions that I think would be appropriate. I'll go over them with in the PowerPoint, and I've put a whole bunch of videos in on proteins, amino acids, Crohn's disease. So these are things, I don't think any of them are over 10 minutes. So I tried to embed them in the PowerPoint, but it's just not happening. My MacBook doesn't like to embed videos. So, all right, let's see what we can do here. All right, so, so what are proteins? So I'm assuming everyone knows what proteins are. They have a concept to it, but please realize these proteins are going to be structural components. So as you eat these things, your digestive tract is going to break them down. Your stomach's going to start breaking them down with hydrochloric acid and pepsin, and we break these great big macromolecules into smaller polypeptides, and then into dipeptides, and then we want to break them back down to amino acids. And basically, we want to take all these amino acids, some of them are essential, some are non-essential. We want to reconfigure them to make whatever we want. So the best analogy that I've been using since like 2009 or 10 is I want you to think of proteins as a big block of Legos that you're breaking down, or let's just say you're consuming them. As they go through your digestive tract, they break down into tiny, tiny Legos, and then through your hepatic portal vein and your digestive tract. We won't get into the mesentery and the splenic, all the venules that go to your liver. Your liver's going to take all those little tiny amino acids. It's going to, through dehydration synthesis, going to pull an OH off of one, H off the other. It's going to make water. It's going to take those 2 amino acids, going to click it together. These amino acids are going to be put together in a very specific configuration, and that is done through the DNA in your cells. It will send the encryptment code basically to the cytoplasm, and then it runs it through your ribosomes, and your ribosomes through codons and codes will assemble these amino acids appropriately. And then as they leave the ribosome, depending on their functional R group, whether it's hydrophilic, hydrophobic, acidic, basic, positive, negative charge, it's going to cause this protein to twist and turn, all right? And that's the quaternary or tertiary structure of a protein. And proteins have a specific structure. So whether they're enzymes or proteins that makes collagen or tendons or muscle or synovial fluid or lubricants or anything in your body, your DNA has that code for it. And these proteins will leave with a certain structure. And then once these proteins are denatured, all right, they no longer function properly. And that's why we don't denature proteins, and that can be done by a problem with pH or temperature or other components that can cause these proteins to denature and they become unstructured, or they change their configuration, whether they're enzymes or substrates or catalysts or whatever, they won't function as well or properly. All right, so I'm going to go over that again as we go through the PowerPoint. That's kind of a brief synopsis of why we're learning about proteins. And I want you guys to start realizing, what proteins you need, whether they're essential or non-essential, whether your body can make them or have to consume them. And then, we could get into, if you guys want to get into it with discussion, if you're missing an amino acid, all right, it can cause disease and a pathology. So these things have to be consumed if we can't make them. Now, whether you're going to be a vegan, flexo vegetarian, a carnivore, or whatever, you need to get these amino acids into your diet somehow. So whether it's mixing rice and beans or peanut butter and bread, or maybe you're ovo flexible, you can eat eggs, or you will eat certain dairy products, or maybe you'll eat fish. But realize if you're eating these protein that's not a complete protein and it only has some, you have to combine these two or three different legumes or whatever it is to get these essential amino acids, and without them you can't make the correct structures for function of your body, right? So top right hand corner, that's edema. All right, so edema happens when you have excess fluid, or if there's not enough protein, albumin in your blood to pull all the constituents back into your cardiovascular system. Fluid starts pooling, and that is right there. That's called pitting edema. So when you push into that, it stays that way. All right. So pitting edema is usually not. It's more viscous of a fluid. Right. And we'll talk about that in a minute or two. All right. To the left is that's a picture of hair. It looks like cousin It from the Addams Family, but whatever. That's hair. So please realize your hair is made up of proteins. Your nails, your skin. Pretty much anything structural in your body is made out of proteins, and your body is going to want to keep these proteins for structure. It doesn't really want to burn them for energy. It can, we'll see coming up, we can start burning the carbon skeleton because it's going to have the same components as glucose and fats. Some component, carbon, hydrogen, and oxygen. So if it's glucose, C6, H12O6, or if it's a lipid, same thing, carbon, hydrogen, and oxygen, and just the ratio might be slightly different with that. But it could, if it had to, use proteins as fuel, but your body really wants to keep the proteins for structure, function, and we do need protein for your immunoglobulins, your antibodies. We need it for albumin in your blood to make sure you don't have edema in the absence of some kind of COPD or something like that. So the functions are to maintain, and repair cells. That's their primary function. Right. So, children that are nutritionally deficient, they're going to have a problem healing. they're gonna have a problem growing. If they're infants and they don't have enough protein, they can have severe brain damage, which will stay with them for life. Right? And proteins are there to build structures. Now, they produce enzymes, lubricants, and clotting compounds. And clotting compounds are important. When you prothrombin and vitamin K, we're going to see in the next chapter, it's produced by some of the bacteria in your large intestine. Without vitamin K and prothrombin, you can't have clotting compounds to clot your blood, so you will bleed out in the absence of a hemophilia or some kind of bleeding disorder. Proteins produce enzymes. Now, enzymes are extremely important. They lower the activation energy for a lot of the metabolic functions in your body. And these, by the way, are the key things when you are talking about denaturing proteins, or if you alter the pH of your blood, or let's say you have a fever for a certain period of time, that temperature can alter, denature proteins. And the first thing it hits is the enzymes. And once you start denaturing these enzymes, your body metabolic functions cannot happen fast enough, and that can cause severe damage or potentially death. Right. We need them for transport substances. So we need proteins in your blood to transport like lipids through chylomicrons, because you guys should know that fat and water don't mix, right? So if we can take these lipids and put them in a protein type M&M, all right, protein around it, then these proteins will they mix well with water, so we can use them as transport vesicles for lipids. We need transport vesicles to get a lot of things into cells. So I'm sure that most of you have heard of insulin, all right? Or yeah, insulin. So a lot of people think insulin is just basically to get glucose into cells. Well, that's true, but insulin can also bring a lot of different substances into cells, and large substances. So that can't go through that biphospholipid layer. We can have transport substances that can actually bring them across the cell. So just when you think of proteins, think of repair, think of structure, things like that. So keep that in the back of your mind. All right, they make antibodies, IgA, IgG, IgM. All right, and these antibodies are what your body uses to immobilize or tag any foreign substance so that your immune system can handle it. Make certain hormones, all right, along with cholesterols and lipids make hormones, and hormones are what regulates a lot of your body functions. Your nervous system is going to regulate them immediately, and then the hormones take over. So if it's something cyclic, or if it's a reproductive hormone, growth hormone, luteinizing hormone, thyroxine, yeah, so a lot of these different hormones. Maintain proper fluid balance and acid-base balance. So these proteins can be used as buffers. So if something's too acidic, we want to make it a little bit more basic. If something's too basic, we want to make it a little more acidic. So by using the OH we'll see coming up, or the H, a hydrogen or a hydroxyl group on these amino acids, we can alter the base. We can keep that pH around 7, 7.4, because we realize if we get pH is too low, we start running acidic at like 6.8, or if we start running very, very basic, 8, 8.1, we're going to denature all our proteins, specifically these enzymes, and that will cause severe disorder and possibly death. All right. And here it says provides energy. All right. So a lot of textbooks, whether it's anatomy, physiology, or biology, or whatever you're reading, or the courses that I have taught before, a lot of the books will say that proteins provide energy. It's true, they can, but your body definitely wants to use it for all these things above here before it wants to use it for energy. And we can use the carbon skeleton, I said, to use it. And if you know about the keto diet or South Beach or a lot of the protein diets, you could just consume a lot of protein. And what will happen is your body will use the protein for what it needs. If it needs energy, it'll start using up your glucose, your glycogen stores from your liver, and then it'll actually start taking your fats or lipids and break them down and run them through ketones for energy. All right. But if it has to, as a last resort, it'll start using proteins. It'll start breaking down muscle mass, and then as a last resort, it'll start using albumin in your blood, and then you have all this pitting edema up here, or if you ever see any of those commercials with the starving children, that's what happens. They've used up everything else, and protein's the last resort. It starts using their muscle, and then it starts taking the protein out of their blood. They have nothing to pull that fluid back into their circulatory system, and they get the major edema in their feet and usually in their stomach, right? Or stomach area, thoracic area. So amino acids are basic building blocks. All right, so start thinking those Legos, and these are building blocks, and we can configure these, and we want in. All right, so they're when we run it through the DNA, they're made nucleotides. All right, take these amino acids in chunks of 3, and each of these codons codes for one specific amino acid, so it adds these amino acids in a very specific order, so that when they leave the ribosome, they twist and turn primary, secondary, tertiary, and quaternary shape, and that's what makes these proteins have a very distinct shape. And that's how they function. Form follows function. All right. There's 20 different amino acids. All right. That's kind of a cool number, but realize that we to consume, we can make the majority of those, but we need to make up, or we need to consume about 9 of those. And I'll go over a couple of them. You know, I'm sure everyone's heard of tryptophan, maybe valine, methylone, some of these other ones. I would never ask you guys to memorize those in this entry-level nutrition course, but if you go on to biochem or something like that, that's definitely something they're going to ask you. So classification are non-essential and essential. All right, just remember, non-essential, your body can make them from regular proteins that you eat. All right, essential means your body cannot make them, you have to consume them. All right, and some bacteria can't make folic acid. All right, it's not an amino acid, but it's a vitamin. Just like that, we cannot make some of these amino acids. We have to consume them, and that's why it's so important to eat properly. And if you're a vegetarian and you're not eating complex proteins, you need to combine certain things together. Complementary. You need to complement, like you know, rice and beans. If people think, well, that, you know, that's Latino or it's very Spanish. Well, it may be, but they knew over time that that combination will give them every essential amino acid they need. Or, you know, peanut butter and jelly sandwiches, by the way, the book talks about it. Another way of pulling legumes and bread together to get all of your essential amino acids. Extremely important. All right, so these are non-essential, all right, which means body can produce them. All right, some of these should be relatively familiar. If you guys are reading labels, I'm hoping you are, but that's clearly up to you. You know, you are what you eat, and whatever you eat, it's going to either do one of two things. It's going to heal you or it's going to harm you. So, you know, you can take the course, you can learn it, you can take it to pass, or you can take it to pass and actually learn something that might benefit you for the rest of your life. All right, so essential. Histidine. All right, now histidine we need, that actually, just so if you go on, is what actually wraps around your DNA to keep it bound in a very specific construction or specific order. So when it becomes unwound by gyrase and other, well, actually the proteins, we can read that code and make other proteins contingent upon what we need. Isoleucine, leucine, methylthione. Usually that's a that can be a start or stop codon for RNA. All right. Phenylalanine, right? That if you can't clear that in your body, it can cause major damage. Tryptophan, we probably all have heard of that with turkey. All right, it's precursor to something else. All right, so what happens to all the protein we eat? So I want you to start thinking about, we're gonna eat this protein, whether it is number 5 from Taco Bell or Mighty Taco if you're in Buffalo, or if it is some kind of rice and beans or whatever you're eating, if you're a vegan or culturally that's what you eat or that's what you're accustomed to eating, whatever it is you eat that you enjoy, whatever you have an appetite for, what's going to happen with it from the point where we consume it, masticate it, chew it, going through our digestive system until we eliminate it. All right. We're going to see the structure of that. And just remember that the amine group, the nitrogen and 2 hydrogen group, we're going to cleave that off usually. We're going to make other things with it. But if we have a plethora of it or a lot of it, we're going to run it through your liver, and your liver is going to convert that ammonia, all right, into urea, something that's less toxic in the blood, and then it's going to be cleared out in your kidneys. All right. So we want to explain what happens to proteins as they undergo digestion and absorption in the human digestive tract. So what are we doing? We're eating that, like I said, we're eating that great big chunk of Legos. What are we doing with it? Explain how cells make protein. I'll do that briefly. You can look that up. And really, it's part of biology, or we teach it in A&P. I teach it in microbiology. All right. Describe what happens to excess amino acids. All right, and you can calculate your recommended daily allowance of protein. So basically, if you wanted to make sure you're eating enough, you take your body weight, you can divide that by 2.2, all right, and then you multiply by 0.8. Or you know what, just divide your body weight by 2.5. It's going to be relatively close, give you a rough idea. All right, so here's the big picture here. So digestion and absorption, construction of protein, we're going to use peptide bonds, right? A dipeptide is 2 amino acids. Polypeptide is a great big chain. And we need polypeptides as we run that messenger RNA through ribosomes, and those codons code for a very specific amino acid. And we put these together. And then when we hit a stop codon or stop signal, it stops, cleaves that. It goes out into your cytoplasm. And depending on what that side group is, that our group, if it's water loving or water hating, acidic, basic, positive, negative charge, it can cause them to attract or repel. Or if it likes water, it's going to twist to the point where that surface is going to be exposed to the outside where the water is. So depending on what that functional group is, and I'll show you, when these great big long change of amino acids, polypeptides, when they actually leave the ribosome, they're going to twist and configure in a very specific way depending on the R group, right? And so I'll definitely ask you guys, what makes, what I could say, well, what makes one amino acid different than the other, right? So they're all going to have a specific backbone or a carbon skeleton, and then what makes it different, or every amino acid has a very specific base and the R unit, whatever's on the carbon. You guys should know that carbon has 4 bonding sites. So we're going to put an acid on one, that's going to be C double bond O and then OH. And then on the other side, we're going to have that nitrogen with 2 hydrogens, and then that carbon is going to have that one other bonding site. And whatever goes on that bonding site is going to make each amino acid specifically different or inherently different. You guys can, I will try to blow this up. Of course not, because I'm MacBook, overpriced piece of garbage. nothing. All right, so you guys can read this on your own. I'm sorry, I'm not in my office. All right, so basically, we're gonna be chewing this up, and just remember that there's amylase um, in your saliva that can start breaking down some of these things, and then we have protease, we can start cleaving proteins, and the hydrochloric acid in your stomach will start breaking these polypeptides, and then we have pepsin in your stomach, which is not active yet. We wouldn't want that active, but it'll start digesting your stomach, right? So we want to wait till we get some protein in there, start breaking those bonds to turn these polypeptides into smaller links, into dipeptides, and we break them up. So our end goal is to get all of these amino acids to break apart. So like I said, we assemble them in the ribosome, but our end goal is to break them all back into amino acids, put them back into the body. They're going to be in the cytosol of the cell. And then as we read the code again, it's going to grab these amino acids with transfer RNAs going through the ribosome and attach these in a very, very specific pattern or specific lineage. All right, and if we have a mistake in that, then we can have a defective protein, and that can be what causes a lot of these other diseases like Tay-Sachs. There's a deficiency in a protein, so we're not able to break down certain things, or people that can't drink a lot of phenylalanine in the diet soda because it can cause some major problems. So that's something that they just can't consume, even though it's an essential amino acid. They have to take it in very, very, very small doses. Okay, so it says when the shortened polypeptide chains enter the small intestine, the pancreas and the absorptive cells secrete protein splitting enzymes and proteases. All right. Proteases digest polypeptides into individual amino acids. All right, so polypeptides are going to, or proteases are going to break that apart. You guys might have heard of protease inhibitors. We can use that, some antivirals. All right, so when these messenger RNA viruses go to literally assemble themselves, right? We can some protease inhibitors. Then they can't break them down, and when they leave the cell, the viral particles are defective. So very, very effective with HIV. I'm not quite sure if they're using it with the new COVID SARS-2. I'm not really sure what's going on with that. All right, and then what we're going to do here is our end goal is to get these microvilli, which are part of your digestive system, to absorb these single amino acids. Then we're going to take them here to the portal hepatic vein. They go to the liver, and the liver is going to reassemble these amino acids into the proteins you need. All right, so if you have liver damage, or you're an alcoholic, or there's a defect in your liver and you can't assemble these amino acids, or if you're missing these essential amino acids, you can't make certain enzymes. We could just say, well, you know what, this person can't make clotting factor. They're going to bleed out, or they can't produce a certain digestive enzyme in the body. Then they're going to have major difficulties. Without getting too in depth, because this is just basic nutrition here. So proteins undergo partial digestion by pepsin. Remember, pepsin is it's not quite active yet until you've got protein and hydrochloric acid in the stomach, and then it becomes activated. We want it to be in its inactive form. We want it to be there. So we don't want to eat protein and then have to wait 12 or 15 hours for the body to produce it. We want that inactive form there. So when we need it, it's there. We just have to activate it. It's kind of like having electricity come into your switch. You want it there, so when you flip the switch, you can use it. You don't want to flip the switch and have to wait for bring the power to the switch. It's already there. It's just inactivated. All right. So further digestion occurs as the pancreas and intestinal cells secrete protein splitting enzymes. So that can be amylase from your pancreas, or it can be protease. And what they do is they just they start cutting that long chain of amino acids, and we start cutting it and cleaving it into these small specific amino acids, and then these small amino acids get absorbed into the microvilli of the intestinal tract, and they're there to increase your surface area. Now, if you guys have heard of celiac spree or IBS or some of these other digestive issues where the microvilli are destroyed, there can be an antigen antibody reaction, or they're allergic to gluten and they're eating it. The body goes to clean up the damage from the, if it's antigenic, your body's going to attach antibodies to it to tag it to tell your immune system, oh wait, I'm allergic to this, or this is foreign. And most of us, we are consuming these foods. Some of our, not too complicated, our T cells will tell the immune system, no, wait, hold on. I know this is foreign to us, but it's still food. So we're going to keep it so we don't have an antigen antibody reaction to it. But if we do, our immune system will go in and start cleaning that up. And as it cleans it up or gets rid of it, it starts to take pieces of the microvilli with it. So at some point in time, watch the video. You guys should know what's going on with that. It starts eliminating your microvilli. So you could be eating all the nutritious food in the world, having a super pure, clean diet, but you don't have enough surface area to absorb these amino acids. Can cause a major, major problem. So the small intestinal cells, final digestion occurs at the absorptive cells and release enzymes from the microvilli. So they're sitting here. These microvilli are going to release a couple other enzymes. They're going to really start finally breaking down those amino acids into the small the 20 amino acids that our body needs to reconfigure whatever we need to construct. After being absorbed, amino acids enter the portal vein and travel to the liver. All right, so it's called the hepatic or liver portal vein. So literally it is how all the food that you eat, whether it's carbs, lipids, proteins, alcohol, whatever you're consuming, preservatives, God knows what is in some of the food, it's all going to your liver. And if your liver has to reassemble those amino acids, or if it's alcohol or recreational drugs or NSAIDs or all the pesticides or chemicals or colorants that you're consuming, your liver has to detoxify that and get rid of it and take whatever components you can use and reassemble them. So very little dietary protein is excreted in feces. If it is, it's a very small amount. And most of it is going to be that amine group, that nitrogen with two hydrogens, because your body's going to really take that carbon skeleton with the carbon, oxygen, and hydrogen. It's going to recombine that to shuffle those carbons, oxygen, hydrogens in whatever order we need to make either some form of energy or some form of fat if we can. Okay, digestion and absorption. So construction of proteins. How is it done? It's done with the DNA. Right? As we read those codons, it takes, like I said, it takes the transfer RNA and with a codon, which is 3 nucleotides together. It has a transfer RNA come in at a very specific point and attach these amino acids in a very specific order on the ribosome. It leaves the ribosome, and then I said it's depending on the R group. Like I said, if it's got a negative charge or a positive charge, or it's acidic or basic, or hydrophobic or hydrophilic, whether it likes water or doesn't. If it doesn't like water, it's going to tuck itself on the inside away from water. If it likes it, it's going to bring itself on the outside. So we can actually have one going one way and one going the other. I don't know if you guys can see me doing that. Okay. That's done in the DNA in your cells. So we have to send the information in. We have to transcribe it, translate it, bring it out with messenger RNA from DNA, and then transcribe it, running through the ribosomes. All right, sickle cell disease, all right, perfect example. So with sickle cell disease, there's a problem with the ribosomes. They misread something. It's inherited in the DNA in the cell. So it misreads it. So there's a problem with the hemoglobin, which is a protein. It's not made properly. So initially it's okay, except when there's a low oxygen environment. All right, so somebody's really working hard or they're labored and they're using up all their oxygen, then the hemoglobin actually unfolds that tertiary shape, and then that red blood cell goes from being round into more of a sickle shape. And then what happens is those red blood cells that are distorted in sickle shape, they start jamming up into your in the circulatory system and the capillary beds. All right, and then everything past that can't get blood, can't get oxygen, and those cells start to die. All right, very, very painful, and it can be very, very deleterious very quickly. And the issue is that they don't even know that it really happens until about age 4 or 5. Advantageous if you have, if you have malaria, um, advantageous to a point, but for most of us, no. So the fate of excess protein, usually we excrete it, or like I said, we're going to take that carbon skeleton and use it, but the nitrogen group, the liver will take care of it. It actually, it's ammonia based, and then what the liver does, it turns it to uric acid, and then it turns to urea, which is we wouldn't want ammonia floating around in our blood. Okay, that would be um, deadly. So if you have major liver damage and you have kidney failure, you're going to have all kinds of ammonia in your blood, and that just is not a good combination. We're going to recycle proteins whenever we can. So even if we're breaking down our red blood cells, we're going to break that apart, and we're going to keep the hemoglobin. Right, heme is iron, and the globin is protein. We're going to break that down. We're not going to excrete that out. We're going to reuse that over and over again. All right. And then daily losses. We have some daily loss to protein, but not a lot. All right. But you can also, if you want to think about it, not to be gross, but we need nitrogen in our soil. That's part of fertilizer, right? So, and plants do a lot of nitrogen fixation. So that's why they used to use animal feces, that extra nitrogen that we excrete out. Right? We can use that fertilizer, and some countries still. I try not to eat food from that country, but they still use human waste as fertilizer. And the issue with that is sometimes they have parasitic things that are in their digestive system, and they kind of put it in the soil, and we'll not talk about it. All right. So here we have digestion and absorption. So here is that amino acid. So there's the amine group, nitrogen with 2 hydrogen. Here's the carbon with 4 bonding sites, right? And I said one is going to be NH2 group. Over here is going to be the acid group, which is always a carbon, double O, OH, carboxyl group, always, right? And then we have our H, and then this is the side group. Now, this is what literally makes each amino acid very specific, is this side group or the R group, depending on how they ask you that, right? So there's your amine group. We can leave that off. I said that turns to ammonia, but your liver is going to turn that into uric acid and urea, right? It's going to be excreted in your urine from the filtrate of your kidneys. Right, so unnecessary amino acids are stripped of their nitrogen-containing portion. Right? So we want to keep the skeleton, because remember, if you look at this, remember glucose C6, H12O6, or a different combination for the lipids. So we're going to take, these are all the components we need. We're just going to reshuffle them around and make something out of it. Maybe convert it to fat or glucose. All right. Used to make non-essential amino acids. We can make that. We can program those into that. The carbon skeletons that remain are converted into glucose or fat, used to make non-essential amino acids or metabolized for energy. Okay. All right, so your protein needs. Now, generally speaking, most Americans in this part of the country here are probably consume more protein than we need, right? But you're going to need more protein under certain factors, all right? Obviously pregnancy, all right? Because your mom has to repair herself and rebuild herself, and she has to literally, make another human being, which is amazing, right? Lactation, so for providing milk, which is a protein source for the children. Periods of growth, all right, protein, I said, they're going to be for growth and repair. Doing physical exertion, all right, so you're using physical exertion, so you need a lot of energy, but remember too, when you're exerting or exercising, you're literally breaking down, you're pushing your muscles to extreme where they actually break, all right, and then when they rebuild stronger because the muscle's saying, well, I'm under a lot of stress, I need to become stronger, so it knows enough to rebuild itself stronger. So just think, if you have somebody who has huge muscle mass, all right, they're usually not making more muscle fibers. They're just whatever muscle fibers they have are breaking down and getting big in size. All right, serious illness or injuries. All right, so once again, you have to think about that. There's going to be a lot of repair going on. Serious illness, you need immunoglobulins for antibodies. You need to start making a lot more memory cells. You need to make more T cells. There's a lot going on. So you're going to have increased demand for protein. All right, so like I said, if you wanted to figure out how much protein you need, take your body weight, divide it by 2.2, and then multiply it by 0.8. All right, and in the morning or sometimes in the afternoon, if I go to LA Fitness and I'm working out and I see all these, I don't I don't want to call them meatheads, but they're drinking massive amounts of this protein, and I'm thinking, dude, there's no way that you need all of that protein. So just remember, if you're eating any excess protein, right, we can save that carbon skeleton, but all that extra nitrogen has to be cleaned out by your liver and your kidneys, right? So it's okay if you're young and you're drinking enough fluid and your kids are and your liver are functioning. That's fine, go at it. But if you are not in great health or you have some kidney issues or you're not in good health and you maybe drink or party too much, you're really stressing your liver out, probably not the best long-term decision you could make. The American consumer consumes 80 grams of protein a day, all right, which is more than you need. So let's just say that you weighed, let's say you weighed 160 pounds, all right, divide that by 2.2, all right. So, roughly off the top of my head, 70, multiply that by 0.8, would be 56, rough math. 56 grams of protein a day. Now you're consuming 80. The average American consumer consumption is 80 grams. It's 15% over what you need for energy intake. Right? You can look at my plate. I'm not going to say it is good or bad. I personally don't agree with all that, but that's just my theory. All right. So protein and foods. Let's just kind of really talk about what food are legumes. So people get tubers, legumes, and things mixed up. All right, explain the difference between a high quality protein and a low quality protein. Identify foods that are rich in high quality protein. So I'll probably ask you a question of these, which is a low quality protein, which is a high quality protein, or I could ask you a question on combining two low quality proteins or three low quality proteins to get everything you need to get all of your essential amino acids in. Plan nutritional meals and snacks that reduce animal protein intake. So if you don't want to eat animal protein for health reasons or religious reasons or ethical reasons, that's fine. But you have to start planning meals. We were supposed to do discussion one was supposed to be on meal planning, and I got in my opinion, I got very limited participation in that. So I was kind of hoping that you guys, or maybe in the future you'll realize, well, how can I plan how to make meals that either, with tofu or combinations to reduce the amount of proteins I eat, or maybe I'm eating more protein than I need, or ethically I don't want to eat meat. I don't know if you guys are members of PETA or whatever. My second cousin was the head of PETA, Heidi. Yeah, she was a little whatever. Develop strategies for reducing your intake of animal protein without sacrificing protein quality. Right. So if you want to go to Lexington Co-op or whatever and buy some tofu, some people will eat just they'll won't eat a lot of animal products, but they'll eat eggs already because eggs aren't actually killing an animal. Right. So good source of protein in food. So meat, pork, poultry, beef, fish definitely. If you go to Peru, I mean, you can eat guinea pig. I was there. I couldn't do it. Tried. And then I ordered fish, and they served me the fish with eyes, scales, the whole thing. I just about threw up. I had to take it away. All right, legumes, tree nuts, eggs, and then some dairy and meat. Sorry, dairy and cheese. All right. All right, so there's just a chart. So I'm not going to test you guys on a lot of this, but just start thinking about how could you start incorporating some of these other foods in here. I am not, your book talks about macaroni and cheese or pasta or bagels or whatever. I personally am not a huge carbohydrate fan, especially refined carbohydrates. Like I said, the human body was not designed, in my opinion, to run on carbohydrates. So some you obviously need a few, but probably not the best source of. It's a good source of energy in small amounts. Just don't overdo it, as far as I'm concerned. And if you learn nothing else in the course, try to limit your refined carbohydrates, and let's really start thinking about laying off the sugar. All right. So sugar definitely diminishes your immune system within 20 minutes of consumption. So not the best option. So high quality complete protein, meat, fish, poultry, eggs, milk, and milk products. Um, I'm going to just mention here that you guys can drink milk, and I'm not saying it's bad. There's ethical, people. I had someone about 4 years ago who did an entire discussion on milk and how she was from the area, and I really gave her a lot of credit. It was talking about milk and how we're taking these cows and we're physically forcing them to breed with males. All right, so we don't want to call it rape, but whatever. We're forcing this to happen, forcing these cows to give birth over and over again, and then we're taking the milk, giving it to the calf, and then after they're done with the calf, we take all that milk and we consume it as humans. And we're literally the only species that I'm aware of that continues to drink milk after we're weaned. Even a calf stops drinking milk after it's weaned. All right, so that was just my little side notes. All right, processed soy and quinoa. All right. Quinoa is actually very, very healthy. I've ever tried it. Very, very good. Low quality, incomplete protein. These are limiting amino acids, and just kind of realize we have to combine these with other low quality proteins. And I'm not saying low quality bad isn't like it's cheap or it's garbage. All right. It's just saying that that specific protein source can have all of the essential amino acids in it. Not saying it's bad. And believe me, if I could live on, if I could figure out a way to not eat meat and enjoy it, and I was, I didn't gain, 12 pounds, I would totally do it. All right. So protein quality. All right. I'm not saying that one is better than the other. We're just saying as far as an all-in-one or if you have to combine. So complementary combinations: tryptophan, lysine, and methylfolate. These are the four that we have to combine. So these may be one of these may be in the incomplete, so you'd have to combine a bunch of them to get all these. All right. So plant proteins: legumes, grains, tree nuts, and seeds. All right. Grains, tree nuts, and seeds, they're usually a little bit higher in carbohydrates, so that's fine. As long as you're not going to over consume these as far as excess carbohydrates, which are going to turn into fat. Legumes generally have less carbohydrates in them and slightly more protein. So not all mixtures of plant foods are complementary protein combinations. So what they're saying here is just because you're eating a whole bunch of plant foods doesn't mean that you're going to get all of the essential amino acids. You could just say, well, I just went to Wegmans or Tops or Piggly Wiggly and I shopped around the periphery like you told me to do, and I grabbed a whole bunch of vegetables and I just ate them. We're not saying that you're going to get all these amino acids. You need to combine them in very specific strategizing ways to do that. All right. So it's kind of showing you like primary limiting amino acids. So seeds and tree nuts, everything except lysine. So all these things are going to have, they're going to be missing some. So you would have to mix all these together to get all the essential amino acids. Right. All right. So stretching your food dollar, or literally doesn't even have to be that. If you just don't want to eat meat. All right. So before the end of the course, if you guys get some time, actually at the end of the course, we're going to be talking about genetic modification. But if you really want some eye-opening, you can start watching things. It was basic. That's been forever. There's Meet Your Meat. There's Seeds of Death. There is all these different movies out there. Forks Over Knives. So if you really want to, or you should know how the food is gathered in America. So the beef is going to be in these feedlots in the Midwest where there's thousands of cattle, barely any grass, or chickens are raised in these buildings with no ventilation, no sunlight, very little fresh air. Some of them are fed grown, and literally, if you guys have gone to the store and you've seen these chicken breasts that are mammoth, all right. When I grew up on a farm, chickens they weren't that big because I grew up on an organic farm. These chickens are genetically modified, some of them, or they're given growth hormones where their um, breasts are so big, and everyone wants chicken breasts. It's their favorite part. That they literally are so heavy they can break their legs. All right. I don't want to get you guys upset, but I think that your generation should definitely know what's going on with the food supply. And unfortunately, your generation is the one who has to speak up, and your power is in whether you buy it or not. I realize it's going to be a lot less expensive to do that, but you have to start thinking about: do you want that chicken with the preservatives and growth hormone? If we were in class, we'd start talking about these, children in South America that worked for Purdue, and they were, the kids were eating all this chicken, and they're realizing that these girls were menstruating at age 8. They couldn't figure out what's going on. Well, yeah, it was all the growth hormones that they were consuming in the chicken. Anyway, I just digressed again. So animal sources and serving sizes, other high quality replacements. So like tofu is a good option. I just found, what did I find the other day? I found this, was that it at Target, and I found it also at Walmart. It's this pasta that's made out of mushrooms. A little pricey. It was like $2 a bag, but it was actually really good. Just start thinking about things you can start replacing or things that might be healthier options for you. Increased percentage of plant proteins and other food choices. All right, so soy, great. That's what tofu is made out of. Whey protein is made from the fluid they make when they make cheese and milk and the cottage cheese. Maybe cheese curds too. Those are delicious, by the way. So what is vegetarianism? So I could ask you guys a question on the difference between vegan, vegetarian, or flexo, or there's all these different combinations. So many that I can't even keep track of them. You have to like look at the name and go, okay, well, that's what that is. And you don't even have to brand yourself. People could say, well, I'm a vegan or vegetarian, but every once in a while they'll want eggs or they'll want fish, or my cousin every once in a while she will have a steak or a burger. But not often. Vegetarianism, semi-vegetarianism, flexitarian. So that means, I go either way, but they prefer to be a vegetarian, but every once in a while, who doesn't want some chicken wings or whatever? Lacto vegetarian, which means they probably consume some kind of milk. All right. Ovo, some kind of egg, or they'll eat eggs and milk, but they won't eat animals. Or some people say, well, I'll eat vegetables and fish, but I won't eat eggs. Or somehow they think that a fish is not a mammal, so it's okay to eat it, whatever their rationale is. Characteristics of a vegetarian diet and vegetarians usually lower in fat, saturated fat, cholesterol, and energy. Right. So obviously, you know what? It sounds healthier to me. Right. I'm just not sure that as humans we were designed to be vegetarians, but that was centuries and centuries ago. Tendency to have lower risk of obesity, type 2 diabetes, hypertension, and certain cancers. That's true. They're eating healthier, but generally, most vegetarians that I know are just healthier lifestyles. They generally don't smoke, they don't drink as much, they might not be doing many pharmaceuticals. But I've been to the co-op over here on Hurdle, and some of the customers or clientele there, um, reek of a certain herb and are drenched in patchouli, but whatever. Higher fiber phytochemicals, which are actually good. They're going to be like in your grapes and wine, antioxidants, free radicals, and that'll come up in chapter 8. I think I put that one together yesterday. Just have to go through and check that out. And that one I did it works. I was able to embed some videos, I hope, in there for you guys. If not, I'll post them into Blackboard for you. So just watch them if you want. You don't have to. All right, folic acid. All right. We're not talking about vitamins right now, but please realize folic acid is vitamin B9. All right, you need to take that in combination with B6. Very specifically needed for DNA replication. All right, so it's crucial for females of childbearing years. I don't care whether you plan on having children or not plan on having children, but please realize you could be 2 to 3 months in before you know that you're gravid or you've conceived. And by that time, you may already have some um, spinal cord issues. Because remember, oh, not remember, maybe you don't know, your spinal cord is the first part of your body to develop. So it's a lot of through the neural tube. There's a lot of neural tube issues that happen if mom is deficient in folic acid. All right, doesn't usually happen. It could, sometimes it's, I want to say young moms or mothers who don't have super healthy lifestyles, so they may be possibly drinking more or smoking more, or they could have other things going on, and they're maybe not eating totally healthy, and somehow they conceive a child and don't know um, till 3 months in that they are pregnant, and at that point there may already be neural tube deficiency, so they can be cleft palate, spina bifida, things like that. Vitamins E and C, potassium, magnesium, other lifestyle practices. All right, so regular exercise, relaxation activities, avoid tobacco and alcohol. So they're just saying vegetarians are usually healthier, but these are some of the things they're going to have much better dietary consumption here. Healthier, they're eating healthier things, but also they usually, in most cases, have healthier lifestyles in general, right? Dangers of some vegetarian diets. All right, now I've seen this in students and in patients, and I've read about it. So low energy, all right, they're not, sometimes they're anemic, all right, so they're low energy, so um, they have anemia, so they maybe have a problem with their red blood cells, iron deficiency anemia, or B12, megaloblastic anemia, because B12 from plant sources, we'll talk about it next chapter, are not as bio available as meat products. So they generally have a problem with megaloblastic anemia, right? So they lack high quality proteins, lack omega-3 fatty acids. All right, so maybe they're not eating salmon or tuna or some of these other foods that are high in omega-3 fatty acids. Lack vitamin B12, that's huge, D, and riboflavin. Without vitamin D, you can't really absorb as much calcium as you should. Riboflavin, B2, this can cause a lot of skin issues. They lack minerals like zinc, iron, and calcium, which are high in animal products. Right? So just realize that vegetarians have to be a little bit more educated in what they eat, and a lot more have to plan things out a lot more than the rest of the population per se. Okay. All right. So young vegetarians may not eat enough protein or energy, and by young we mean that they're, if mom and dad are vegetarian or vegan or whatever, their kids are going to be raised that way, and the kids are growing. Mom and dad have to figure out ways of getting them more protein and energy. So it might be more tofu, um, some higher quality carbohydrates, so they have enough energy and protein because they're healing and they're growing, right? Lactating mothers may produce milk inadequate in vitamin B12. That's a huge issue. Growth and development issues in children, and B12 deficiency can lead to megaloblastic anemia and a lot of neurological issues. And yeah, we'll leave it at that for now. All right. I'll say discuss why high protein diets are generally not recommended for healthy people. Explain the cause of food allergy. Identify foods that are most likely to cause food allergies. All right. And we'll talk about celiac disease. I also want to get into, before the end of the course, and I'll bring it up again, Roundup and glycosamate that's used, pesticides and fertilizers that are used, and these non-organic farms. My father and I had for years about Roundup and pesticides, and he still thinks I'm crazy, but they're finding out now that with cross pollination, and they're finding out that Roundup is literally in the groundwater. It's in rain now. And these plants are absorbing it into their root structures. So you could be buying kale and all these vegetables thinking you're eating healthy, and meanwhile you're consuming a bunch of Roundup. And Roundup literally just can destroy your microvilli. It can destroy all the gap junctions of all the cells in your digestive tract. So what happens is these cells break apart, and great big chunks of protein. We talked about the amino acids being broke, or the polypeptides being broken to dipeptides in a single amino acids. They're literally coming in chunks, polypeptides, and other things that shouldn't be able to get into your digestive system in that peptic portal vein. Then it goes to your liver, and your liver is like, what the hell is this? You're supposed to be sending me a single amino acid. You're sending me these great big globules of protein. Can cause a whole bunch of issues. So excess protein intake is not recommended for normal, healthy adults. All right. Like I said, I'm going to say that that's okay to state, but some people want a high protein, low carbohydrate, medium amount of lipids, and they are much healthier on that, especially if you're pre-diabetic, or some people just don't do well on carbohydrates. A lot of them, it makes them very, very lethargic. So it spikes their glucose, blood sugar, makes them uh, spikes it, and then it makes them very, very lethargic. So they do better on a high protein and lipid diet. But once again, the caveat is you have to drink enough fluid, your kidneys have to be functioning. And remember, any of that excess nitrogen is going to be released in your urine, and any excess protein that your body doesn't really use or can't use, it's going to be excreted in your feces. Right? All right, some loss of calcium with that, and that can cause problems with sometimes the bone density, and a lot of times calcium, if it's excreted through the kidneys, if it comes out of solution in the ureter, it can lead to a lot of kidney stones, which are very, very painful. Dehydration, we don't want that to happen. If you're dehydrated and you're losing calcium, then for sure you're going to make less filtrate, less urine. The calcium is going to come out of solution, and the ureter can cause a lot of kidney stones. All right. Liver and kidney issues. Like I said, if you're eating way too much protein, or um, you have some kind of GI issue, irritable bowel syndrome, and leaky gut. I just discussed that with Roundup and a lot of these pesticides and chemicals is destroying the microvilli, and it's causing all these gap junctions. So your digestive tract is outside of your body, and it's designed to absorb things into those microvilli. But if the cells come apart and things can get in that shouldn't be in there, it can wreak major havoc on your digestive system. I'm just saying here, once again, if we cleave this amine group off of that carbon skeleton, it goes to your liver. Your liver is going to turn that into urea, uric acid and urea, and then we excrete it as urine. So excess protein, we can consume it, not a problem. You have to have a healthy liver. You have to have plenty of fluid, so make urine. Your kidneys have to be functioning. Generally not a problem. I wouldn't recommend that to a 70 or 80-year-old person, unless, I would probably suggest that somebody who is majorly obese, if you want to lose some lipid or excess fat, I would say cut out those carbohydrates, eat more protein, some lipids, just routine exercise, walking. All right, I wouldn't just be able to burn off some of that energy, and it would be much healthier than being 100 pounds overweight. Right. So athletic needs, muscle breakdown, rebuilding. So if you are on a serious exercise regime, and I mean 3 or 4 times a week in the gym. Um, I won't even get into what I see at LA Fitness. People just don't even know what they're doing. They're just compressing discs and fracturing vertebrae and ugh. Anyway, adequate energy from carbohydrates and fats to provide activity. Right? So you want to just increase your carbohydrates and fats, and just remember it's always better for your body to use carbohydrates and break down fats for energy than breaking down protein. Protein sparing, your body wants to use protein for like blood clotting, healing, hair, replenishing your GI tract, all of that stuff. It's much more useful doing that. Your body can use protein for fuel, but it's really the last resort, regardless of what you've read or been told. Right. So protein supplements, I'm not a huge fan. I don't think that I personally don't think it's a great idea unless you are seriously like, I don't know, if you're going to, I live right next to UB. So if you're at UB and you're on the football team or UB sports or you're a serious athlete, maybe. Okay. But general population, probably not. But if you're taking, steroids and working out and doing all that stuff, that's your business. I don't know what to say. Not recommended for normal, healthy adults. All right, can cause amino acid absorption imbalances, can be toxic. All right, and I'm not going to put down any one country over the other, but please realize where this is coming from, and just please realize that a lot of this stuff is not highly regulated. I don't want to get negative about our government agencies, but I'm not sure that they really have the average consumer, their health in mind, or we wouldn't be having genetically modified organisms and plants and spraying the massive amounts of nitrogenous fertilizers that used to be um, defoliants. Yeah, some of this stuff was leftover chemicals from um, the Vietnam War and Agent Orange and things like that. So these can put a lot of stress on the kidneys if you're consuming just way too much protein. All right. And that's, a huge issue with not South Beach so much as keto. I was like, oh, the keto diet. I'm like, well, yeah, it's been around since the well, it first started in the 50s. It was in the 70s, and now they're saying it's huge for people with epilepsy and all these things. But yeah, it's been around for um, Atkins has been around since the late 60s, early 70s. Very, very similar concept. Right. So protein deficiency is uncommon in the US. Usually it's for problem with the chronically ill or older adults. They're not eating um, as much. They may not be as hungry. They may have problems swallowing. And a lot of times too, like people don't realize without good teeth, it's very, very hard to chew. And some people, don't eat because their teeth are so bad it hurts, or if they can't really chew their food enough, they can choke. So these are the things that your book doesn't talk about. Your book talked a little bit about um, it being expensive to eat high quality proteins, and they may have to use their money for medications for other health issues. Um, I'll speak carefully, but I really think that if more people um, were a little bit more concerned about what they ate and really mindful about what they eat, there wouldn't be as many health issues in this country. So maybe a little bit more exercise, a little bit more concern about what you're consuming and putting in your body. You may end up not um, having as many medications as you get older. I'm in my late 50s and I don't take any medication at all. And when I go to any kind of doctor, they look at me like, what? What do you mean you're not on? Why aren't you on um, some cholesterol medication? Why aren't you on blood pressure medication? Why aren't you on whatever? I don't know. So protein, energy, malnutrition. So, adults versus children in developing countries, a lot of times, food may be scarce, and if mom is breastfeeding, a child, and then somehow, miraculously, unbeknownst reason, she becomes pregnant again and has another baby, then she has to feed the newest baby, and the older infant, may be under 2 years of age. There's not going to be enough breast milk for both of them, and mom may be tapped out too. Okay, effects of undernutrition and low protein intake. And your book's going to talk about, or people will say, well, we need genetically modified food to feed the country and feed the world. And the truth is there really isn't a food shortage anywhere in the world. It's a transportation issue. All right. And if you guys want to do any research about um, Bill Gates, or how they were going to industrialize all of the food processing in the world, and they went to like India, and where these people had these farm practices they had for generations, and they saved their seed, and everything was great. And then they said, well, we're going to bring in uh, machines to help you increase your productivity. You buy the seed from us, and he will loan you the money for the machinery, and it's rep ready. Um, and a lot of these, 60% of it failed, and there's, I don't want to get depressing, but a lot of times they just took over all of this land. Used to be family farms that used to be able to feed entire families or villages, and now these are going to be, they're just completely wastelands devoid of any mineral content, because they're planting the same thing over and over again, and all these pesticides and herbicides are killing the microbiome and the soil, and the soil is completely depleted. And we'll talk about that later on. It's depressing enough. All right, so protein and health. So food allergies. All right. So some people are legitimately allergic to foods like peanuts, shellfish. These can cause um, hypersensitivity type 1 anaphylactic issues, where the inflammatory process is so crazy that literally most of the blood volume leaves the capillary bed, and the inflammatory process brought on by the mast cells and everything, that people swell up, and they can die from this. But please realize some people can be food intolerant. All right, so some people, if they drink milk, or if they have ice cream, or eggs too, they have a problem digesting it. They don't have an allergic reaction, but they might be food sensitive or food intolerant. Doesn't really mean they're allergic to it. Right? So if they're allergic, you have a definite response to it. And some people are allergic to sulfate. Um, Sometimes cooked meat, the benzene rings, they have a reaction to. But you can be tested for that. There's a picture here. Um, I have a picture of myself being tested for some things, and everything came back completely negative. But I know for a fact I'm allergic to patchouli, and I'm definitely allergic to raw tomatoes. Break out into a rash and hives and everything. But it showed up negative on the test when we went in. And then one year, one of my students told me that, oh, this, no, Dr. Phil, don't worry. We have people coming in all the time, and they test negative, and these tests are only like 50% accurate. I'm like, oh, that's great. All right, so gluten, huge subject right now, a huge problem with people being gluten intolerant, and just realize they're allergic to this. So they have the gluten, it comes from these wheat, rye, these products, and usually it's the hull of the wheat. It has an antigenic particle the body recognizes as foreign. We have antigen antibody reaction. we clump it together, then the immune system has to come along and clean that up. And it's stuck to the microvilli. So as they do it, it starts eroding away the microvilli. There's a really good video I put in Blackboard. So just please get in and watch that. I'm not going to test you on the specifics of it, but you should get a picture in your mind of what's going on with this. So signs and symptoms, they'll have extreme bloating, discomfort, and then eventually their microvilli will wear away. And I said they're going to be consuming all the right stuff potentially, but there's no way of the microvilli absorbing that, getting it to the hepatic portal vein to get it to the liver. All right, gluten-free diets, there's a lot of benefits to that. All right, so gluten, the video goes into how there's certain antigenic markers, HLA markers that each human has, and there's different classifications of, you get one from mom, one from dad, and if you get the right combination, you're going to be much more sensitive to gluten. It'll register as a foreign particle, and your body will rightfully so think it's foreign and have an antigen antibody reaction to it. But I also want to throw out there, we'll talk about it again, that with these genetically modified organisms, plants and animals, all right, they may be producing proteins that the human body was not designed to consume. So I'm going to theoretically say that, if humans are allergic to gluten, what's to say that with these antigenic particles and the HLA markers, that they're not also allergic to genetically modified tomatoes or corn or salmon, because we're going in and gene splicing the DNA. So when we go to replicate that DNA, we're putting the messenger RNAs going to the ribones and putting these proteins together in sequences that they've never done before, they weren't supposed to be doing in the genome of the original animal, because we've gene spliced it. Just going to throw it out there. But what am I? Just a crazy hippie. All right, so that's chapter 7. I'm going to be going over chapter 8. I'm hoping to do it tomorrow, and I'll post that. So I am going to end the video. I will be grading your discussions. I want to say I'm a bit disappointed. The microbiome discussion is still up if you want to do that. Slightly disappointed in that too. So, you guys can put as little effort as you want or as much effort as you want. You can learn whatever you want. You can learn nothing. It doesn't, I don't want to say it doesn't matter. It does matter to me. But it is your choice. I realize, like I said, it's a bit of a depressing time, but spring is here. Hopefully the sun is out. Let's perk up a little bit. We've got 6 or 7 weeks here to get all this done. You've got plenty of time to learn this. I will be putting the tests up. Take them whenever you want. Within reason. All right, I'm not going to put test 1 back up again, 8 weeks later. That's not going to happen. So, all right. Anything, email me. All right, let me close all this up. Stop sharing, I think.